Hello there, Mr. Thompson here with a video math lesson on prime factorization, which is a pretty fancy way of just saying expressing numbers or writing numbers as a product of only prime numbers in index form. Okay, so we're taking numbers, we're rewriting them as only prime numbers and using index form. Okay, so what the heck does that mean? Well, let's just look at an example, and it's pretty easy to see and pretty easy to do. So we're going to take the number, well, we've got some steps here, sorry, getting ahead of myself. Step one is find the prime factors. Okay, so we are going to look at a number here, 48. Okay, and what we want to do is just take some numbers that multiply to equal 48. Okay, so the factors, right? So two easy numbers that we know multiply to 48 are 6 and 8. Okay, now if these are prime numbers, then we stop, but neither of these are, right? Each of these can be divided again. So 6 is a product of 2 and 3, right? 2 times 3 is 6. And 8 is 2 times 4. Okay, now 2 and 3 are prime, so those ones are good, right? But 4 is not. 4 is 2 times 2. Okay, so now I'm going to identify, we've got all these prime numbers, 2, 3, 2, 2, and 2. Those are kind of the end of the line, right? We can't divide these anymore by whole numbers. Okay, so we've got our prime factors. Step 2 is to combine equal factors into index form. So we've got all these 2's, right? 2, 2, 2, and 2. Those are the equal factors. These are the like factors, right? They're all the same. Okay, and not only that, we've got 4 of them, right? So basically what you've got here with the 2, 3, 2, and 2, and 2, what you're saying is 2 times 3 times 2 times 2 times 2 is equal to 48, right? And you can test that out, right? 2 times 3 is 6, times 2 is 12, times 2 is 24, and times 2 is 48, right? So what we're going to do is we're going to take the 2, and since there's 4 of them, we're going to write it as 2 to the 4th, right? 2 times 2 times 2 times 2 is 2 to the 4th, okay? And then times 3. There's only one 3, so 3 to the 1, or just 3, right? And this 2 to the 4th times 3 is equal to 48, right? You could plug that into your calculator if you want, or you just know that 2 to the 4th is, well, 2 times 2 is 4, times 2 is 8, times 2 is 16, right? 2 to the 4th is 16, times 3 is, of course, 48. All right, let's look at another example. Let's do 108. All right. Now, the easiest thing to do, if you look at 108 and you say, oh man, I'm not sure what divides into 108. Well, the easiest way to do even numbers is just, well, divide it by 2, right? All even numbers are divisible by 2, which then gives you a prime factor right off the bat. Okay, so what's 108 divided by 2? Half of 108 is 54. Another even number, we can divide it by 2, and 54 divided by 2 is 27. 27 is no longer even, but it is divisible by 3. And 3 times 9 is 27. And then again, 9 is 3 times 3. And there we have a bunch of primes. 2 times 2 times 3 times 3 times 3. Despite these last two examples, you will get lots of prime numbers, prime factors besides 2 and 3 when you start doing these with other numbers. Just happens my first two examples just come down to 2's and 3's. But anyway, now we want to gather up the like factors, the equal factors. So I have 2 2's and I have 3 3's. So I'm going to rewrite this as combine the 2's into 2 squared, right, and 3's into 3 cubed. And that's all there is to it. 2 squared times 3 cubed is 108. 4 times 27, 108. So there you go. That's prime factorization. Pretty simple. And best of luck, and see you next time.